All right, I'm gonna go ahead and get started because I somehow was very ambitious in what I wanted to fit into today's lecture. So I'll give us our best chance at getting through it, and I'll go ahead and start now. Today we're talking about marsh loss, which is the topic of your final project, because I cannot possibly get through all the intricacies of this issue in one lecture, which is why I've assigned it to you for a final project, because you'll be able to delve into some of these topics more. So we're going to cover the causes of marsh loss, restoration projects in Louisiana, and a couple of different concepts and activities, including climate refugees and invasive species. The learning goals for today are to understand that before human interference, the interaction of natural processes led to an actual increase in land in the region, and so that has led scientists to believe that land loss is a human-caused phenomenon. Louisiana's land loss involves at least 4 main factors: reduced sediment flow, subsidence, sea level rise, and the construction of pipelines. You'll learn that projections suggest that in a future without action, the next 50 years could result in the loss of almost 2,000 additional square miles of land, which is almost as much as we've lost already. So we could see a doubling of land loss. And you'll learn that we are going to act, so thankfully there won't be a future without action. So there are various efforts to restore the Louisiana coastline, and these represent one of the most ambitious restoration projects of all time. Land loss in Louisiana is the challenge of our time. So we have in Louisiana the land essentially washing away. And with it, we're losing a lot of what makes Louisiana unique. So with its going many unique and beautiful ways of life and cultures, we have New Orleans that sits right in the middle of the disappearing land and is highly vulnerable and will become increasingly vulnerable as the land disappears around it. And marsh loss in our region represents one of the first major impacts that the U.S. is dealing with related to climate change. We're expected to have to deal with climate change on a large scale and much faster than the rest of the world. In terms of assignments, so I got a question in chat about assignments. So there were 2 homeworks assigned for this week. One of them I intended to have due today, but I ended up clicking next Wednesday, and so now the homeworks are due next week. Because I'm not going to change those times and make it due earlier than it says. So there are 2 homeworks that are still active right now that are reading related, right? And then you do have coming up due next week your current event number 3. And that's due, I believe they made that due on Monday. So I'll make sure you work on that. So we learned about delta switching. Over about the past 5,000 years, the Mississippi River built the land of southeast Louisiana through delta switching. You can see the process through here of the Mississippi River building up land as it moved back and forth in this region. And then Europeans colonized the region, and since then the land has disappeared at a rate equivalent to the size of a football field every hour. So as we're having this lecture today, we can expect that a football field worth of land is being lost from coastal Louisiana. It's a pretty wild amount. And as I mentioned, this was not happening. This land loss was not happening before human interference. So that's why it's believed that this is a human-caused phenomenon. This is something that we've done to the system by our presence here. In total, the state lost just under 2,000 square miles of land between 1932 and 2010, and this is an area over 1.2 times larger than Rhode Island. So essentially we lost Rhode Island worth of land before 2010, and as I mentioned, we're expected to lose about that much again if we don't act. Rhode Island doesn't exist. We lost Rhode Island. So major causes for this land loss, there are 4 main factors. One is reduced sediment flow from the Mississippi River and its tributaries, because, as I've mentioned before in lecture, we've channelized the Mississippi River to flow through one location and not do any more delta switching. So now it's stuck in one location, and most of the sediment is delivered to the Birdfoot Delta, where it is swept out into the Gulf, and it's not available for land building. The second factor is subsidence, or the sinking of land, and this occurs naturally as soft river sediments settle and are compacted. So over time, this will happen naturally. But there are human activities that speed it up, such as extraction of groundwater, oil, and natural gas in the coastal area. And we do a lot of that in Louisiana. Of course, sea level rise plays a major role, and we talked about that in the last class. So if you need an update on sea level rise and you weren't in the last class, please do watch that video that's posted on the lecture slides from last week, or from Monday. And then finally, the construction of oil and gas pipelines, which I will talk about in detail in the next slide. Also important are damaging hurricanes, which can take away large swaths of land at a time, and invasive species such as nutria, which we will cover in one of our activities for today. Okay, I promised to go into more detail on pipelines, so here it is. Pipeline construction for oil and natural gas is frequently followed by local marsh erosion. So you can see in this image a location without any pipelines in 1956. We have this first pipeline built through here, and you notice in the next image a lot of land has been lost around the edge of this pipeline. And the second pipeline is built, and by this third image in 2008, a lot of land is lost around that second pipeline. The reasons for this loss are, well, first, there are direct impacts from the damage of dredging the canals. So there are large canals that are dredged in some case. These two canals here are probably flotation canals, and these types of canals cause most of the damage. They're about 250 feet wide. They're dredged with a dragline or a backhoe mounted on a barge, and they can be used to run pipelines or for access for maintenance purposes. This is not the only way to lay pipeline. So not all pipeline has to be this damaging to put out there into the environment. So pipe can be laid in smaller ditches that are backfilled to do less damage to the environment. So you can still have marsh grass recolonize. Or you can have pipeline inserted directly into the sediment without any digging, except for at the sediment surface at the point of entrance and the point of exit. And so this way, directional drilling only disturbs the surface sediment at two small locations. So we've chose to dig these canals this way. It didn't have to be this way, is the point I want to make there. Canals change water flow patterns across the marsh. They allow waves and rushing water from tides to travel further into the marsh. They're creating new erosion problems where erosion didn't exist before by letting the water travel quickly to these locations. The loss rates are highest soon after the pipeline is laid, and then they drop off over time. And the impacts are greatest immediately around the pipeline. About 500 feet around the pipeline is usually worn away the fastest and the most. All right, let's go ahead and do our quiz. All right, which of the following are major causes of Louisiana's marsh loss? More than one answer may be correct. Please choose all of the correct answers. All right, let's continue on. Charging ahead. So what are the stakes of all this land loss? Why do we care about it? There are a variety of reasons. Are you guys able to see my lecture okay? Like, am I cutting out at all? Because I can move to Zoom if the lecture's messed up. Okay. Okay. All right. Well, let me know if it becomes a problem, because I can always switch to Zoom. So projections suggest that in the future, without action, we can lose about the same amount of land as we've already lost all over again, 1,750 additional square miles of land. if that happens, our new coastal cities right up against the coast will be Houma and New Orleans. They'll just be essentially coastal destinations. Inland communities will have far inferior protection from hurricanes because we'll essentially have open water all the way up to Houma and New Orleans. And so that means less land for hurricanes to go through and dissipate energy before they reach those two cities, and also before they reach other inland cities like Baton Rouge. Substantial money will need to be spent to move oil and gas infrastructure at Port Fourchon and Venice because the land underneath those two locations is disappearing. Entire communities will lose road connection to the rest of Louisiana and will face relocation. And this includes barrier island communities like Grand Isle. And so there will come a time, for those of you that are going to continue living in this area, there will come a time when the government has to decide whether or not to continue building a road or a bridge out to Grand Isle. And so that's a real discussion that we'll have to have. So what will this do to culture in the region? Certainly some pretty drastic changes in culture. We're going to have entire groups of people, entire unique cultures that have to relocate. Sometimes they may choose to relocate altogether and to keep their cultures in place, but sometimes they may scatter all over the place. And so aspects of culture will likely be lost. Fishermen who have moved inland will have longer travel times through shifting shallow marsh to get out to the Gulf. And so the fishermen are still going to have to get out to the Gulf of Mexico, past all of this fragmented marsh, past the barrier islands, which will still be there in some form, just not as large. If they're living in places like Houma, that's a really, really long commute. And so they're going to be using more fuel. This includes, commercial fishermen and recreational boats. So, what will this do to our sportsman's paradise? I mean, it's going to be increasingly hard to get out into saltwater to catch fish. These are just some things that are likely to change. There are certainly a lot more impacts that you all can probably think of. Many of you have lived here a lot longer than I have. So you probably have some other impacts in mind that may occur if this amount of land is lost. And this image here in red is showing you all the land that's been lost previously, and then in yellow is all the additional land that we stand to lose before 2050. And the problem won't stop in 2050, so it'll continue on after that. A little scary. Okay, so I'm going to have you guys do an activity now on climate refugees. This one shouldn't take you too long. So I'm going to give you like 10 minutes on this one. We'll loop back together at 10:55. So there are two activities. Make sure you're choosing the right one. Climate refugees. Okay, so this story just it really breaks my heart to think about what's happening to the people of Ile de Jean Charles. This is something that they're having to deal with a long time before we know how to deal with it, and so we haven't been having as many discussions as we should about what we need to do with climate refugees. So I asked you to think about what's meant by the term climate refugee, and hopefully a lot of you somehow came up with some definition revolving around the fact that there are people that have to move, they're refugees because of climate change, in this case sea level rise. And so we talked about this a little bit when we talked about the Maldives in the last lecture, how there's going to be a refugee crisis in a lot of these areas that are coming to terms with climate change first. And so one of these places is Louisiana. If you live in this area in Baton Rouge, this is going to be the place that a lot of refugees head because we're on relatively higher ground, but we're still close enough to the coast that, it's attractive for people to live here. This happened after Hurricane Katrina. A lot of people who lost property in New Orleans ended up moving to Baton Rouge. And so Baton Rouge will definitely be affected by climate refugees in terms of moving in. And then climate injustices. So this article brought up the fact that climate change and its impacts often hurt the people who are underprivileged, people who are in poverty or minorities. They hurt those people the worst. And so the idea of environmental justice or climate justice involves dealing with an issue in a way that gives everybody the benefit, but especially the people that are feeling the impacts the worst, and especially the people that can't afford to deal with the impacts. And so I'm not forgetting about the people who are impoverished and dealing with climate change, but instead focusing on them and bringing them some sort of justice for all of the injustices they've had to experience at the hands of climate change. Or any sort of environmental degradation. This happens a lot with pollution, like for instance, Cancer Alley, which is our lovely area that I live in, that is full of industry. A lot of minority and people who are impoverished live in this area and have to deal with the pollution a lot more than people who live outside it. And we'll talk more about that when we talk about pollution, because that lecture's coming up. Okay. So, what's the solution? Let's talk about the solution. If you came to my digital field trip, you definitely saw this map or something similar on the wall. I think on the wall I had push pins of all of the different locations of restoration projects throughout southeastern Louisiana. So, examples of restoration projects that are happening are structural protections, oyster barrier reef creation, shoreline protections like riprap, barrier island restoration and marsh restoration, big sediment diversions, hydrologic restoration, infrastructure building. So these are all things that our state is doing to stem our losses, to stop our losses, and to promote land building so we can have some time to deal with the consequences of sea level rise and hopefully not lose a whole bunch of our state. This is a huge restoration endeavor. There's not anything like it in the whole world. So you're going to be looking for kind of like similarities and differences with other locations for your final project. And I think you'll find that, a lot of the other locations that are dealing with shoreline retreat, it's not nearly on such a large scale, and they aren't doing nearly as much as we are in this state to stop the losses. So let's talk about some of the things that we're doing. This is definitely a multi-pronged approach. One of the things that we're doing is using breakwaters, living shorelines, and terracing to, as like cheap and relatively easy efforts to slow and dissipate wave energy and to trap sediment. So breakwaters help to slow waves. I don't know why my screen keeps doing this. Slow waves and prevent erosion. This is a picture of a breakwater installation project in Grand Isle. You'll notice that they're staggered to allow people and animals to move through this area so they're not destroying the connectivity. Terracing, this is an image of terracing here. So it involves the construction of a series of vegetated bars to diminish waves, increase sediment deposition, and reduce the rate of shoreline erosion. These are relatively new in this picture, so you can't really see any vegetation, but the bases of the terraces are planted with marsh cordgrass, Spartina. And the design allows commercial and recreational fishermen to get in between them and to use the space for fishing. So it's definitely serves multiple purposes. Establishment of bioengineered oyster reefs. So by bioengineered, I don't mean that we're bioengineering the oysters, not necessarily. So what I mean is these are shoreline protection devices that are engineered devices that provide habitat for oysters for the purpose of establishing new oyster reef, and this oyster reef will dissipate the wave energy as it approaches the coastal marsh. And so the idea is that these will serve to protect the marsh, they'll serve to trap sediment and maybe build up the marsh. The oyster reefs are great because they can keep up with sea level rise. They can actually grow vertically, and so these would be long-term solutions that wouldn't need constant maintenance, at least that's the point. They have a lot of benefits, including providing a source of oyster larvae to aquaculture. These types of reefs oftentimes attract fish to them. Despite all these benefits, there really hasn't been much money set aside for this effort. So if you're focusing on any of these for your final project, you can definitely talk about, what value you think they have. Oyster larvae. So those would be small, like essentially baby oysters. Oysters, as well as most marine critters, have a larval form. Yep, they're considered larvae when they're young. Yep, so they'll have a larval form. They look totally different from the adult oyster, and they move around in the water. So they'll drift around with the water. It's weird, right? Yeah, I try not to say baby animals because, babies are a human thing. But yeah, oyster larvae would be the word for a baby oyster. So these reefs are producing essentially baby oysters that can go and settle on aquaculture reefs for people to harvest. So that's a win-win. Cute little larvae. Marsh restoration. So thousands of acres of marsh have been restored in coastal Louisiana. Actually, if I were to go back a couple of slides, you can see all of this green here is area where we've done marsh restoration. And all of this red along these barrier islands here are areas where we've done barrier island restoration. So lots of area. To do this, sand is dredged from offshore sandbars, submerged sandbars that are offshore, and delivered to areas designated for restoration. You can see an example here of sediment delivery at Bayou DuPont. This is before. It's pretty much all water except the edges of the channels that have been drilled for dug for pipes, and then this is after. So you can see all this area has been filled in with sediment from offshore. In some cases, you'll have volunteers and consultants then come in and plant marsh grass. And then these activities are often paired with things like breakwater construction, terracing, because they can protect the marsh that's built. Barrier islands are, of course, a major target for restoration because they serve as the first line of defense on our coast. They protect the marshes from the worst of the wave energy and therefore prevent further erosion. Marsh restoration is real expensive, but the nice thing about it is each restoration project is designed as a one-time cost. Ideally, if you build marsh and take actions to prevent it from eroding away, it should be able, if it's healthy, to keep up with sea level rise. And so the idea is that these are a one-time cost. They don't have to have constant resupply of sediment. We'll see if that pans out. Okay, so there's another effort that involves an invasive species that has been, it's a little bit different from all of these others. Like, it's not a restoration effort, but it's been accomplished by the same agency that's carrying out all these restoration efforts. And it's to get rid of an invasive species called nutria. So I'm going to go ahead and give you guys the rest of class to work on the neutralizing nutria assignment, but let me finish up my lecture. Yeah, I know a lot of people think they're real gross. Let me finish up this last slide for you all, and then I'll just set you on your task. So I want to talk about sediment diversions, which are a huge portion of the most ambitious restoration project of all times. Essentially, what they're going to do is reconnect the river and restore natural processes that initially built the delta. And the goal is to capture and divert sediment from the Mississippi River through these locations where the sediment and the water will be funneled through and then deposited into a basin, which is this light brown area, to build and maintain land. When constructed, each diversion, this one's the first one here, the Mid-Barrier Terracing Sediment Diversion, which will be built first. Each of these diversions will be capable of diverting about 7.5% of the Mississippi River. So we're essentially punching a massive hole in the Mississippi River and reestablishing that flow. Modeling indicates that river diversions strongly affect the salinity. So the salinity is going to change in this area. And that might change habitat for many species. For instance, many oyster culture areas in this region will become newly unfavorable to oyster growth, and so that's a huge concern for the Gulf oyster industry. Also, it might have consequences for other species that we care about. For instance, if you love dolphins, they're quite sensitive to salinity, So oftentimes when we have a lot of flooding, there will be a lot of dolphin mortality, and so there's concern that these diversions might impact the dolphin populations in Barataria Bay. The construction, operation, and maintenance of these is very, very expensive, and this is where most of our restoration money is going. So essentially, it better work, right? We're spending most of our money on this. It's also a long-term commitment. To run this, to operate this at times where it's ideal, to maintain these structures so they don't become a massive liability to the people that live on the other side of them. All of that will take a lot of money. So those are some of the options, and I will let you go, and for the remainder of the time, go ahead and work on the nutria activity. All right, it's 11:20. I know this was a long activity, but I thought it was fun. So just do your best and get through what you can. And I'm gonna leave this up. So if you want, additional time to work on it, I've also opened back up the quiz. It'll be located in 22 in class, so you can go through and click the quiz here if you didn't get a chance to take it. And I won't see you on Friday, because Friday is Good Friday. So have a good Friday. And I will see you on Monday.